Welcome to the A320 Flight Instruments and Displays lesson. In this lesson, you will learn how information is generated, controlled, and displayed on the flight deck. In addition to the normal flight displays, we will also discuss the standby instruments available to the pilots. The Electronic Instrument System, or EIS, displays flight, navigation, system, and status information on 6 identical liquid crystal displays. Each display is referred to as a display unit, or DU. The EIS is composed of 2 subsystems, the Electronic Flight Instrument System, or EFIS, and the Electronic Centralized Aircraft Monitor, or ECAM. The EFIS provides both pilots with all normal flight instrument and navigation displays. The ECAM provides aircraft system displays, fault monitoring, and corrective procedure checklists. Controls for screen display options and switching functions are located near the DUs. Standby flight instruments are installed for the unlikely event of a total EFIS failure. The Air Data Inertial Reference System, or ADIRS, is a critical source of information for aircraft systems and computers. The ADIRS supplies relevant information such as aircraft attitude and heading, altitude, airspeed, vertical speed, temperature, wind speed and direction, angle of attack, and G-force. Much of this information is presented through the EIS. The ADIRS is comprised of 3 individual Air Data Inertial Reference Units, or ADIRUs. Each ADIRU is separated into Air Data Reference Information, ADR, and Inertial Reference Information, or IR. The ADR portion of the ADIRU receives information from the pitot-static system. The IR portion of each ADIRU is responsible for determining the aircraft's present position and attitude. The ADR portion of ADIRU-1 receives information from the captain's angle of attack, or AOA probe, total air temperature, TAT probe, pitot tube, and static ports. The ADR portion of ADIRU-2 receives information from the first officer's AOA probe, TAT probe, pitot tube, and static ports. The ADR portion of ADIRU-3 operates as a standby system and receives information from a standby AOA probe, the captain's TAT probe, a standby pitot tube, and standby static ports. The IRU portion of each ADIRU receives information from 3 ring laser gyros. These are used for detecting changes in orientation and spin. Each ADIRU has 1 ring laser gyro for each flight axis, roll, pitch, and yaw. This equates to a total of 9 ring laser gyros for the entire aircraft. In addition, each IRU receives information from accelerometers. The accelerometers measure changes in acceleration and gravity-induced forces. Each ADIRU has 1 accelerometer for each flight axis, roll, pitch, and yaw. This also results in a total of 9 accelerometers for the aircraft. The ability to sense changes in orientation, spin, and acceleration results in each ADIRU being able to independently determine heading, attitude, G-forces, acceleration, and given an accurate starting point, the aircraft's position. The information received by each ADIRU is then sent to 3 display management computers. The display management computers, or DMCs, collect and process information obtained from aircraft sensors and systems. This processed information is then sent to the electronic instrument system, which is displayed on each DU. During normal operation, DMC-1 provides information to the captain's PFD and ND, and both ECAM DUs. DMC-2 supplies information to the first officer's PFD and ND. DMC-3 operates as a standby computer and can supply information to any DU. Two System Data Acquisition Concentrators, or SDACs, gather information from aircraft sensors and transmit the data to the DMCs. The DMCs use the data from the SDACs to generate system display pages and engine operating parameters. Information from the SDACs is also sent to two Flight Warning Computers, or FWCs. The FWCs use the SDAC data along with aircraft sensor data to generate warnings and cautions. The FWCs also generate oral alerts such as radio altitude,
500,
decision height callouts,
minimums,
master caution single chimes, and master warning continuous repetitive chimes. Additionally, attention getters located on each side of the glare shield illuminate to indicate red for a master warning or amber for a master caution. The FWCs monitor the status of the DMCs. If a DMC fails, the display units controlled by that DMC will display an invalid data message. The FWC will generate an ECAM fault message and applicable action steps. The EIS DMC selector on the switching panel will be used for manually selecting DMC3 to regain the display information. In contrast, the FWCs do not monitor the status of individual display units. If a single display unit fails, the screen will go blank or distort, but there will be no ECAM fault message. The ADIRS is controlled through the ADIRS Control and Display Unit, or CDU. Note the numbering sequence of 1, 3, and 2 which is used on the CDU. This corresponds with ADIRU-1 being associated with the captain, ADIRU-3 functioning as a standby, and ADIRU-2 being associated with the first officer. The rotary mode selectors are used to individually select each ADIRU on and off. NAV is used for powering the ADIRU normally. ATT is used in response to a partial IRU failure. When ATT is selected, the IRU only provides attitude and heading information. The ADR push buttons are used to turn off the ADR portion of each ADIRU in the event of an ADR fault. The IR align and fault lights provide information relating to the alignment status of each IRU and inform you of IRU faults if they occur. The white align remains illuminated as IRU alignment is taking place. A flashing align light indicates a disruption in the alignment process. Depending on the nature of the failure, the IR fault light may also either illuminate steady or flash. A steady fault light indicates a total IRU failure. A flashing fault light indicates a partial IRU failure where attitude and heading information may be recoverable. The ADIRUs require both AC and DC power to pass their initial self-test. Once aligned, the ADIRUs use AC power primarily, with DC battery power as a backup. The on-battery light illuminates for 5 seconds when initially rotating each mode selector from off to nav. This verifies each IRU can operate on battery power. In the event of a partial IRU failure, the CDU keyboard can be used to regain limited function of the associated IRU. The display data and display system selectors are used to select and display navigation data and ADIRS status information on the CDU data display. The display data switch allows you to select the type of data displayed. The display system switch allows you to select the ADIRU for which data will be displayed. The switching panel is used in the event of an EIS failure. If the ADR portion of an ADIRU fails, ADIRU3 can be used to replace the faulty ADR. This is accomplished by rotating the air data selector to either Captain 3 or First Officer 3 as appropriate. Additionally, if the ADR portion fails, it should be deselected by pressing the respective ADR push button located on the overhead panel. If the IR portion of an ADIRU fails, the Attitude heading selector is moved to either Captain 3 or First Officer 3, which uses data from ADIRU 3. The Electronic Flight Instrument System, or EFIS, provides all primary flight instrument and navigation data. This information is presented on the Primary Flight Display, or PFD, and on the Navigation Display, or ND. Information presented on these displays is controlled in part by the EFIS control panels. Both the PFD and ND have a brightness control knob which is also used to turn on the display. There are two brightness control knobs for each ND. Rotating the inner knob clockwise powers the ND. It also varies the general brightness of the ND. The outer knob controls brightness for both the GPWS and weather radar displays. During normal operations, the ND is displayed inboard of the PFD. If the PFD fails, automatic logic transfers the PFD image to the ND. However, should the ND fail, no automatic transfer function exists. In this case, it is possible to transfer the PFD using the PFD-ND transfer push button. Notice the ND indications are now displayed on the outer DU. Colors are used on the EFIS displays to depict the importance of the indication, message, or failure, or to separate information into groups. The general rules for colors are as follows. Red indicates a failure requiring prompt crew awareness. Amber indicates a condition requiring general crew awareness. Green is used for engaged flight guidance modes, flight director commands, NDB nav-aid information, and FMGC navigation information. White is used for titles, display scales, and VOR nav-aid information. Blue is used for armed flight guidance modes, VOR CDI, and tuned nav-aid display. And finally, magenta is used for messages and indications which identify flight plan constraints and to depict ILS nav-aid information. Most primary instrument indications on the PFD correspond to instruments found on traditional aircraft. These indications include attitude, airspeed, heading and track, barometric and radio altitude, and vertical speed. PFD indications that relate to the autoflight system include the Flight Mode Annunciator, or FMA, a ground roll guidance command bar, and the flight director command bars. Indications on the PFD are controlled from its respective EFIS control panel. During an ILS approach, the PFD displays capture and deviation information. The lower right corner of the PFD displays the altimeter setting in either standard, inches of mercury, or hectopascals. Flags appear if a component failure affects any of the information presented on the PFD. The PFD presents attitude information in much the same way as a traditional attitude indicator. A fixed aircraft symbol depicts the aircraft with two simplified wings. The center box represents the center axis or nose of the aircraft. As the aircraft turns, the bank angle is depicted perpendicular to the horizon. The angle tick marks are provided at 10, 20, 30, and 45 degrees. The side slip index depicts lateral acceleration on the ground and side slip or yaw in flight. When the side slip is centered on the bank index, a minimum drag configuration is achieved. Pitch angle is depicted in 2.5 degree increments between 30 degrees nose up and 10 degrees nose down. If aircraft attitude becomes excessive, large red arrowheads point in the direction necessary for restoring a normal attitude. Present heading is located on the center of the heading scale. The pilot can use the heading knob on the FCU to select a desired heading. If the selected heading falls within the display range, it displays as a blue triangle. If the selected heading falls outside of the range, it displays as a blue digital indication. Current ground track is depicted as a green diamond. These heading track indications are all also found on the ND. If an ILS or localizer inbound course has been selected, a dagger marks the course. If the inbound course falls outside of the display range, it displays as a magenta digital indication. Indicated airspeed is displayed as a moving scale on each PFD. The indicated airspeed scale moves behind a fixed yellow reference line and triangle, which indicates the present indicated airspeed or IAS. As airspeed changes, a trend arrow depicts the airspeed the aircraft will attain in 10 seconds if the present acceleration or deceleration rate remains constant. The current Mach number displays when the aircraft speed is greater than 0.5 Mach. A triangle on the airspeed scale identifies the target airspeed. The target can either be manually selected by the pilot or managed by the FMS. If the target airspeed is outside the display range, it will display as a digital indication. Airspeed limitations for both maximum and minimum operating airspeeds are displayed for the selected aircraft configuration. Depending on aircraft configuration, the maximum operating airspeed is referred to as VMO, MMO, or Vmax. The altimeter is displayed as a moving scale on each PFD. The aircraft's barometric altitude is displayed in the center of the scale. The altitude scale also displays target altitudes. Target altitudes can be either pilot selected on the Flight Control Unit, or FCU, or programmed as constraint altitudes in the FMS. If the pilot selected target altitude is outside of the display range, it is shown as a digital indication at the top or bottom of the altitude scale. If a pilot selected target altitude falls within the altitude scale display range, it is presented as a blue box. As the aircraft approaches the target altitude, the altitude window pulses yellow. If the aircraft deviates from the target altitude, the altitude window pulses amber. The radio altimeter or RA indication appears in green at low altitudes and becomes larger as the aircraft nears the ground. At decision height, if one was entered, or at 400 feet above ground level, the indication changes to amber. Landing field elevation is depicted as a blue bar extending across the altitude scale. Its value is based upon the pilot's barometric altimeter setting and the landing field destination programmed into the FMS. The ground reference elevation appears as a red ribbon on the side of the altitude scale. This ribbon is based upon the radio altimeter. When the aircraft has touched down, the top of this ribbon will be at the middle of the altitude scale. The vertical speed scale uses a stationary scale and an analog needle to show current vertical speed. There is also a digital readout of the vertical velocity. If the rate of climb or descent exceeds preset limits, the indication turns amber. If vertical speed exceeds 6,000 feet per minute, the needle remains stationary at the top or bottom of the scale. Unlike a traditional static-derived VSI, which slightly lags, this VSI uses IRU data to produce an instantaneous indication of vertical speed, known as an Instantaneous Vertical Speed Indicator, or IVSI. If the IRU vertical speed signal is unavailable, Air Data Reference, or ADR, will automatically provide a backup barometric signal. This signal is less stable than the inertial vertical velocity and will lag the actual value during rapid changes. Whenever a backup barometric signal is used, an amber box surrounds the digital vertical speed indication. The Traffic Collision Avoidance System, or TCAS, commands vertical maneuvers to maintain or increase separation from TCAS intruder traffic. The TCAS fly to or avoid areas are depicted on the VSI. Each PFD is controlled by its respective EFIS control panel. The EFIS control panel is used for adjusting barometric pressure, displaying ILS information, and selecting the flight directors on or off. The baro reference selector is used for setting barometric pressure. The baro setting can be referenced on the baro reference display and on the lower right corner of the PFD. The selector has two rings. The outer ring is used to set the barometric reference units to either hectopascals or inches of mercury. The inner knob is used to set the barometric pressure value. As you climb through the transition altitude, pulling the baro reference selector sets the barometric reference to standard. Standard now appears in both the baro reference display window and on the PFD. The ILS push button is used for displaying raw ILS information on the respective PFD. When selected, a green light illuminates within the push button and an ILS course indicator appears on the heading scale. The ILS identifier, ILS frequency, and DME distance, if available, also appear in the lower left corner of the PFD. The FD push buttons on the EFIS control panel are used to select the flight director on and off. Notice the flight director bars have been removed from the PFD and the green light is no longer illuminated within the push button. When the FD push button is selected on, the green light illuminates and the flight director bars flash momentarily. The navigation display, or ND, presents navigational-related information in 5 selectable modes: ROSE ILS, ROSE VOR, ROSE NAV, ARC, and PLAN. Each mode can be independently selected on the ND's respective EFIS control panel. In general, the following information is displayed: the aircraft position symbol, aircraft heading, selected heading, a ground track diamond, ground speed, true airspeed, wind direction and speed, selected nav aid information and associated bearing pointers, range marks, and when the chronometer push button is pressed, a chronometer display. Additionally, flags appear if a component failure affects any of the information presented on the ND. ROSE ILS displays ILS raw data in a format similar to a traditional HSI. In the center of the display is the selected ILS localizer course, represented by the magenta dagger, a course deviation indicator, and a deviation scale. A glide slope scale and indicator is also located on the right side of the display. Additional information, including the selected ILS receiver, frequency, course, and ILS identifier, are all presented in the upper right corner of the display. The selected ILS approach appears in green when the crew has entered an ILS approach into the flight plan. Orientation for the ROSE ILS is relative to the aircraft heading. ROSE ILS is normally used as a backup to the ILS information displayed on the PFD. The ILS-1 receiver provides information to the captain's PFD and the first officer's ND. The ILS-2 receiver provides information to the first officer's PFD and the captain's ND. Therefore, if the ILS-1 receiver fails, ROSE ILS would allow the captain to fly an ILS approach. Similar to ROSE ILS, ROSE VOR displays VOR raw data in a format similar to a traditional HSI. In the center of the display is the selected VOR course, represented by the blue dagger, a course deviation indicator, and a deviation scale. The arrow on the course deviation indicator represents the traditional to-from indication. Additional information, including the selected VOR receiver, frequency, course, and VOR identifier, are all presented in the upper right corner of the display. VOR approach appears when the crew has entered a VOR approach into the flight plan. Orientation for ROSE VOR is relative to aircraft heading. VOR ROSE is normally used for monitoring raw data during non-precision approaches. It can also be useful for monitoring your position relative to an airway when given an airway intercept clearance. ROSE nav presents a 360-degree moving map display. It depicts current aircraft position relative to the FMS entered flight plan route. The active FMS flight plan is represented by a solid green line connecting the flight plan waypoints entered in the MCDU. Waypoints are normally displayed in green. The to waypoint, which is defined as the next waypoint on your route, is shown as a white diamond. The waypoint name, bearing, and distance to the waypoint and the estimated UTC time of arrival over the waypoint are also shown. Arc mode provides a partial compass rose view of approximately 90 degrees. It provides all of the same information as ROSE nav, but in a more forward view perspective. Therefore, this mode is commonly used for navigation. Plan mode orientation is referenced to true north and is normally used during pre-flight planning. The aircraft's present position is displayed and the position symbol is oriented to aircraft true track. The entire flight plan can be displayed by scrolling through the waypoints using the MCDU arrows. Since the plan mode is centered on a waypoint, the aircraft position symbol may or may not be displayed. Plan mode does not display nav radio information when the associated radio selector switch is in the ADF or VOR position. However, ground speed, true airspeed, wind direction and intensity, and active waypoint information are still available. Each mode can display ranges from 10 to 320 nautical miles. This is indicated by the white range rings and indicated value. In arc mode, the selected range represents the radius of the arc. In the ROSE nav and plan modes, the selected range represents the diameter of the ROSE. The optional data display push buttons on the EFIS control panel are used to display data on the NDs. Information can only be displayed in the ROSE nav, arc, or plan modes. When selected, a green light illuminates within these push buttons. When the constraint push button is pressed, speed, time, and altitude constraints that are in the flight plan will display adjacent to the constraint. Pressing the Waypoint push button displays database waypoints or fixes that are not part of the flight plan in magenta. The VOR DME push button displays VORs, DMEs, and VOR DMEs that are not tuned in magenta. Pressing the NDB push button displays NDBs that are not tuned as magenta triangles. The Airport push button displays the airports that are in the database in magenta. Note these airports may or may not be suitable for emergency landings. The ADF VOR selector switches allow you to display raw NDB and/or VOR data on the ND. ADF information is displayed in green on the ND. The NDB frequency is initially displayed once the switch is placed in the ADF position. The ident and bearing needle is then displayed once the NDB signal is received. VOR1 information is displayed in the lower left corner of the ND. The VOR1 frequency is displayed until the ident is received. Once the ident is received, the VOR three-letter identifier is displayed along with DME information if available. The VOR1 bearing pointer is depicted as a single white needle. VOR2 information is displayed in the lower right corner of the ND. The VOR2 bearing pointer is depicted as a double white needle. Standby instrument indications are displayed on the Integrated Standby Instrument System, or ISIS. These indications include attitude information supplied from ADIRU1 and ADIRU3, as well as from its own internal gyrometer, airspeed and altitude information supplied from the standby pitot-static system, and localizer and glide slope information from ILS-1. ISIS power is supplied by the aircraft's battery to ensure the unit is powered during an electrical emergency. The screen's brightness is automatically controlled by photosensitive cells located on the display. However, the crew can manually adjust the brightness using the plus and minus buttons. The current altimeter setting is displayed on the bottom of the screen and is set using the barometric selector. Pressing the ILS push button displays the localizer and glide slope indications. Airspeed and altitude bugs can be set using the Bugs push button. Up to 4 airspeed bugs and 2 altitude bugs can be set. The plus and minus buttons are used to select the desired bug. Pressing and rotating the knob sets the desired value. If there are any errors in indicated attitude, the indication can be reset by pressing the Attitude Reset push button for at least 2 seconds. The reset takes approximately 10 seconds to complete. The standby compass is displayed by pulling down on an access panel located on the overhead panel. A deviation card is installed on both sides of the compass. The standby compass switch located on the interior light panel is used to illuminate the standby compass. The Digital Distance and Radiomagnetic Indicator, or DDRMI, provides a backup display for VOR and DME nav-aid information. The DDRMI heading information is normally supplied by the captain's ADIRU. The Digital Flight Data Recorder, or DFDR, records the last 25 hours of flight data on a fire and shockproof tape. The DFDR is automatically energized under the following conditions: on the ground for a 5-minute period following the application of aircraft power, on the ground with an engine running, or continuously when airborne. After the second engine is shut down, the DFDR is powered for an additional 5 minutes. The DFDR tape can be marked by pressing the DFDR event push button located on the pedestal. This allows an event to be recalled for subsequent data analysis. One main independent clock is located on the right side of the center panel. It's normally powered by the aircraft batteries. However, an internal battery can power the clock for up to 50 hours. The clock provides a time reference to the FMGCs and other systems. Prior to flight, the date and time are verified correct. If the clock is set improperly, FMS time parameters and predictions may be incorrect due to the clock's relationship with the FMGCs. A printer located on the pedestal can print reports from ADIRS and the CFDS while on the ground and in flight. The slew button is used to advance the paper after loading. Extra rolls of paper are stored in a compartment located above the fourth occupant's jump seat.
That is incorrect. 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 That is correct. That is incorrect.